In case you wanted to see a few extra examples, I'm going to put 3 more examples up here. Okay, and again, remember, we're only going to use one side of the equation to work with until we get the same thing that's on the other side. It does not matter if you start on the left or the right. You can start on either side. Okay, so on this one, I'm going to start actually on the right side so that you can see that it works both ways. But if I were starting on the left, I would want to notice cosine squared. The square clues me in that I might look at a Pythagorean identity. Okay, but if I'm going to start on the right side, cosecant minus sine, one thing I could do would be to change cosecant to 1 over sine, the reciprocal identity. And since that one's written as a fraction, I'm going to put the sine over 1. Okay, now this is similar to example number 1. We have to subtract fractions, so we're going to need a common denominator. So I'm going to multiply the second fraction times sine over sine, which gives me 1 over sine minus sine squared over sine. Okay, and once I have the same denominator, I can write it all as one fraction with my common denominator on the bottom. The top would just be 1 minus sine squared. Okay. Now, I'm trying to get cosine squared over sine. And again, clue in on the fact that your exponent is squared. Anytime you see something squared, there's probably a Pythagorean identity for that. So if you look at your alternate forms of the Pythagorean identities, it should say that 1 minus sine squared is equal to cosine squared. And cosine squared over sine is what we were trying to get. So now we're finished. Again, I could have started on the cosine squared over sine and worked my way till I got cosecant minus sine. But it doesn't matter which side you start on, as long as your work in between is correct. Okay, so number 4. This time I would not start on the right side because the right just says secant. It's very difficult to take one function and expand it into multiple. But if I've got 3 functions on the other side, then I'm going to start by, I can't add those together the way they are, and I've got 3 different functions. So let's change everything to sines and cosines. So let's leave this as cosine. We're going to leave the sine like it is, but tangent has a quotient identity. Tangent is equal to sine over cosine. And since that's a fraction, I'm going to make the rest of these into fractions by putting them over 1. So now I've got cosine over 1 plus sine squared over cosine. To add fractions, we must have a common denominator. So our next step, logical step, would be to get a common denominator, which is cosine in this case. So I'm going to take the first fraction and multiply the top and bottom times cosine. So that gives us cosine squared over cosine plus sine squared over cosine. And once your denominators are the same, you can combine this into one big fraction with the denominator being cosine. And on the top I've got cosine squared plus sine squared. Now again, you've got those squares on your trig functions. Look at your Pythagorean identity page and you will see that sine squared plus cosine squared is equal to 1. So that top part is just the same thing as 1. The bottom stays cosine. And 1 over cosine is one of our reciprocal identities. The reciprocal of cosine is secant. That happens to be what we were trying to get. So now we're finished. Okay. One final example to look at. And again, it would not matter on this if you start on the left side or the right side, but with that plus sign, it's probably going to give me more options to start on the left side. And I'm going to change these into the quotient identities so that we have fractions to work with. So cotangent is the same thing as cosine over sine. Tangent is sine over cosine. Okay, we need a common denominator. So our common denominator this time is going to be sine times cosine. So the first fraction needs a cosine. The second fraction needs a sine. Whatever it's missing, anything the other one has that this one doesn't, that's what we're using. Okay? So what does that give us when we multiply it out? The first fraction ends up being cosine squared over cosine sine plus sine times sine is sine squared over cosine sine. And since the denominators are the same, I can put this into one fraction together. So cosine squared plus sine squared over cosine sine. Now, we just looked at this one in the last problem. Sine squared plus cosine squared is a Pythagorean identity, and sine squared plus cosine squared is equal to 1. Okay, so 1 over cosine x sine x. Okay, now I'm not finished yet because look at what we're trying to end up with. I need to split that fraction up. Okay, so if I write that as 1 over cosine times 1 over sine, that would be the same thing as 1 over cosine sine. And 1 over cosine is equal to secant, while 1 over sine is equal to cosecant. So that takes me to secant times cosecant, which is what I was trying to get to. Okay, you've got to know your identities. If you were not in class, then you are going to work on Trig Identity Worksheet 4. This is due on Thursday before the test, but you only have to do problems 1 through 6, number 8, 11, 12, and 14. Try them. Don't come for tutoring with a blank page. You've got to try something first.